Hello, my friends. Our topic is golden mean aspects. I spent an enormous amount of time over the past several weeks to months investigating golden mean aspects, and at long last I have some conclusions. So I'm making this video in September 2025 with some new insights into golden mean aspects. Now, as you may know, or maybe you don't know, Theodor Landscheidt introduced the idea of golden mean aspects. Maybe somebody mentioned it before him, I don't know, but he did a lot of investigations into the golden mean aspects, and he popularized the idea, and he came up with specific ideas on what the golden mean aspects are. Because a big challenge in using golden mean aspects is that there are many possible golden mean aspects, hundreds of them, and we don't have an a priori way of knowing exactly which ones are the most important. Some of them may be meaningless, and should not be used at all. So that's the challenge, and that's what I've spent a long time investigating, and I've got some information to present to you about this. So what Landscheidt did is he identified a few of these golden mean aspects that he thought are important. So are Landscheidt's golden mean aspects the only ones? I think if he was still alive, he would say no. Are they the most important ones? Well, let's see what we found out. They certainly do rank among the most important. So he was, my investigations indicate that he's clearly on track, and I think he understood that this was an ongoing pursuit that would be perfected over time. So we're taking it to the next level. Here's what I came up with: 35 golden mean aspects. There are actually more, but 35 that I am guessing are the most important. So I have here in green highlight, I came up with 35 golden mean aspects. These are my best guesses, and I'm going to show you how I came up with this, and I'll show you what they are. We're going to look at chart wheels. This will probably take more than one video to cover all this, because I like to make each video roughly a half hour long. So we haven't perfected our understanding, but I feel confident that this information is a big step forward in understanding golden mean aspects. Let's review a few things about golden mean aspects. This is going to be important for understanding why I selected certain golden mean aspects as the most important. So let's cover a few fundamentals. We see here in the upper left a line, we're calling that C. And this line C, we have a little reddish bracket at the top. That whole line is divided into two pieces, and we'll call those A, the larger one, and smaller one B. Extremely simple idea. Just take a line and cut it somewhere. So here's the thing about the golden mean. Suppose that the length of this line is 3 inches or 3 centimeters, 3 meters, whatever. I'll call it inches, 3 inches. And suppose the larger segment is 2 inches and the smaller segment is 1 inch. So C equals 3, A equals 2, B equals 1, 1 plus 2 equals 3. Okay, so what is the proportion? Well, obviously, A is twice as big as B. If B is 1 and A is 2, is twice as big. And what is the ratio of the whole line, which is 3 inches to 2 inches? That's 1.5. Okay, big deal. So the larger segment is twice as big as the smaller segment, and the whole line is 1.5 times bigger than the bigger segment. Okay, big deal. Well, here's the big deal about the golden mean, is is there a proportion? I have here in the middle of the screen a little bit towards the bottom. Is there a proportion where instead of 2 and 1.5, instead of the big to the larger one being 2 and the larger, A to B being 1.5, is there a proportion where it would remain the same? This would mean it's proportionally getting bigger at the same rate. It'd be like a growth spiral that's perfectly smooth. Well, there is. The proportion is 1.618, etc., etc., etc. It goes on forever. Very often it's rounded off to 3 decimals because you hit a 0, so it's a pretty good rounding at the 3 decimals. 1.618. In other words, if this whole line is 1.618 times bigger than A, then A will be 1.618 times bigger than B. This is the golden proportion. The proportions just grow evenly. And there's more to this. This is just the start of understanding this kind of perfect beauty, perfect proportion that happens with the golden mean. Now, by the way, C is 1.618 times bigger than A. So if I reversed it and I said, what proportion of C, the whole line, is A, it's 0.618. So it's kind of cool that you end up with the same decimal number. So A is 1.618 times big, no, let me say that again. C, the whole line, is 1.618 times bigger than A, and that means that A is 0.618 of the length of C. So it's just very neat how that works out. And notice that in the original example I gave, where C to A is 1.5, that means C divided by A is 1.5, A divided by C is 0.667. You don't end up with that kind of thing. And it's just, there's a lot of cool coincidences and things that happen with the golden mean. So the reason I'm mentioning this is that very often you'll hear that the golden ratio is 0.618. And when I say it's 1.618, you might go, no, where did 1 come from? Well, it's both, okay? So sometimes people say the golden ratio is 0.618, and sometimes they say it's 1.618. It's the same thing, just from which side you're looking at it, you might say. Now, here's one of the awesome things about the golden ratio. What if you continue? What if I take A here that I've got in this black box, and I take the golden mean of it. I take the golden ratio of it. If I take 0.618 of the length of A, I'm going to get a smaller distance, of course, and that distance happens to equal B, which is 0.382. So in other words, in row A, I've got the whole line. In row B, I've divided it at 0.618. That means that A is 0.618 and B is 0.382 of the whole line, because 0.382 plus 0.618 equals 1. So actually, you can think of the golden ratio as dividing a line into 0.618 is the larger size and 0.382 is the smaller size. Those are the proportions of the whole line. And then when you take the golden mean of the golden mean, you take 0.618 to 0.618, you end up with 0.382. So there's this beautiful thing that happens with the golden ratio. You take golden ratios of golden ratios, and you end up with the same proportion you had earlier. So it's very elegant. There's something very unique and special about this golden ratio. Now, what if you took a golden ratio of a circle instead of a line? So, in other words, take 0.618, that's the golden ratio, of the 360 degrees. How many degrees do you get? 360 times 0.618 is 222.5 degrees. More precisely, it's 222 degrees, 29 minutes and 32 seconds, rounded off to the nearest second. So it's 222 degrees. That's more than halfway around, because 0.618 is more than halfway. And the shortest distance, remember, golden ratio always makes two segments, a bigger one and a smaller one. The bigger one is 222.5 degrees. The smaller one is 137.5 degrees. More precisely, 137 degrees, 30 minutes and 28 seconds. That is called by biologists the golden angle. This proportion of a circle shows up in nature, in many things in nature. So you have this beautiful mathematical ratio, just like pure mathematics, and it does show up in, for example, many kinds of plants are arranged by the golden ratio. Interesting. So you can think of the golden ratio on a circle. Very often we think of it in the shorter distance as 137 degrees, 137 and a half degrees is how most people describe it, because it's very close to exactly 137 and a half degrees, actually a very tiny bit more. Okay, so the line, if we start here, this is a zodiac where Aries is on the left, so that's 0 on the left. 222 degrees would take us, 222 and a half degrees would take us 12 and a half degrees into Scorpio. So from here, if I start here on the, on the left, I'm going to have a line going up here, almost to the middle of Scorpio. That's the golden angle, as they call it in biology. Okay, now, if I go 137 and a half degrees in the opposite direction, doesn't matter which direction I go. Here, I was assuming we're going counterclockwise. If we go clockwise, whether you go counterclockwise or clockwise is kind of arbitrary. This zodiac is counterclockwise. But if I go counterclockwise 222 degrees, I've got 137 and a half degrees. Takes us slightly past the middle of Leo. Now, if we take golden means of golden means, I start here on the left at 0 Aries, and I go 137 and a half degrees. I end up here slightly past the middle of Leo. Now I'm going to go another 137 and a half degrees, and I end up here at what astrologers would call 5 Capricorn. Now I'll go another 137 and a half degrees, and I end up here towards the end of Taurus. And then I end up over here, and I keep going. I just keep going around 137 and a half degrees. Now I end up over here in late Aquarius, and now I end up over here in the middle of Cancer. And I just stopped at this one in early Sagittarius. These are just degrees from 0 to 360. And you end up with this kind of odd shape. It looks a little bit like, almost like a lopsided star, if I had, and then it starts continuing, just kind of sort of random. Well, there's an interesting thing that happens by going 137 and a half degrees around the circle. What happens is you have the least overlap possible. In other words, these points that we go to do not sit on top of each other. It spreads them out the most evenly. There's a beautiful image of this on a website. Let me show it to you. I didn't have my browser up, so let me put in this website, gofiguremath.org. Sorry about that. This will just take a second. Let me get my browser in this window, and let's go to gofiguremath.org/blah, blah, 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 this long website address. And this is very interesting. He shows the golden angle. Here he started at the top and went clockwise. You could start anywhere you want, about 137 and a half degrees. And what's beautiful about going 137 and a half degrees, he says the golden angle, 137 and a half degrees, they call it the golden angle in biology, is very important if you are a plant. He puts that in a humorous way. Because if you are a plant, it will help if each leaf comes out 137 and a half degrees away from the previous leaf, because it'll get sunlight. If it's here, if it's directly underneath, that's not good. He puts a big red X. The one underneath is just not going to get sun. I mean, if you go every fourth, then obviously after 4, you're back into not having sunlight. If you want the leaves, lots of leaves to get a lot of sunlight, what angle should they rotate by? The golden angle of 137.5. And here he shows it. Here's one leaf, here's 2 leaves separated by the golden angle. This is the same exact thing I just showed you in the chart wheel. Now we've got 1, 2, 3, 4, 5. After you get 5, it looks kind of a little bit of a not perfect 5-pointed shape. And here he's gone up to 13, it looks like is his last one. And you see that each leaf is getting some visibility, which means it's getting some sun. So nature uses this golden angle. It also makes things very compact. So there's a sunflower, and the sunflower seeds are arranged every 137.5 degrees. And then an interesting thing is, if you do 136.5, you subtract a degree, you get this kind of beautiful spiral. And if you add a degree and do 138.5, you get a different kind of spiral. And here's what happens with the golden angle of 137.5 degrees. So this is information about the golden angle, like what it is mathematically, how it's been found to be important in nature and why it's important. Okay, this all leads up to a background to help us better understand how we would apply this to astrology. So here's what we start seeing in astrology. If we take the golden angle and we go counterclockwise, which is the way astrologers often go, Aries, Taurus, Gemini. We start at 0 Aries. As I mentioned before, we end up at almost the middle of Scorpio. It'd be 12.5 degrees of Scorpio. Now, if I take the golden mean of the golden mean, which is what I was showing you before at the line, we take the golden mean of the golden mean, we end up with 137.5. We end up with the same angle, because this 222.5 is 137.5 in the opposite direction. This immediately gives us the intuition that taking golden means and golden means makes sense. When you take the golden mean of the golden angle, you end up with the same angle again. Your shortest distance is the 137.5. 137.5 degrees is the super golden aspect. You know, I think using this term golden angle is a good one. They use it in biology. It's the primary one. Intuitively, I mean, common sense would tell you it's the strongest, most important one. So the most powerful golden mean aspect is the 137.5. That seems pretty clear. Now, if I take the golden mean of a golden mean, I end up with 85 degrees. And if I take the golden mean of 85 degrees, I get 52.5 degrees. And if I take the golden mean of 52.5 degrees, I get 32.5 degrees, roughly. So that's the sequence of golden means. You could look at these like levels, going from 137.5, then take the golden mean of that, 85, then 52.5, and then 32.5. So I show that here. You can pause this and read this. Now, you know, if you want to go over all that arithmetic. But now, here's Landscheidt's idea. Is in astrology, we use the shortest distance. We usually take 0 to 180. So instead of doing golden means of all 360 degrees, what if we start doing the golden mean of 180 degrees? That's one of his ideas. So we have these golden mean aspects that we just discussed. These are the golden mean aspects: 137.5, 85, 52.5, 32.5, and you could keep getting smaller and smaller and smaller as far as you want. But again, let me say this again, just make sure you got it. Instead of starting with 360, let's start with 180. So I put a red circle here at 180 from the starting point, and if I take the golden mean of that, what do I get? 111.2. So Landscheidt sometimes calls the ones based on 360 degrees conjunctions, and the ones based on 180 degrees oppositions. Now, the ones based on 180 degrees are not oppositions in the same way an aspect is an opposition, but it's based off the opposition aspect, starting with the golden mean of 180. So we can call these opposition golden mean aspects if we want to. And the first one is 111.2. And then we take the golden mean of 111.2, we get 68.8, and the golden mean of that is 42.5, and you can keep going. So these are the primary conjunction golden mean aspects, 137.5, 85, 52.5, so on. And then we have the opposition golden mean aspects, 111.2, 68.8, 42.5. Okay. Now, by the way, if you take 0.382, that kind of, you might say, complementary angle, complementary proportion, you end up getting these same numbers. So, and I will show that to you later. Okay, so these are the golden mean aspects according to Landscheidt. Now, the idea of supplementary angles. In mathematics, they're called supplementary angles, but I sometimes call them complementary angles, which is technically incorrect, or co-angles, which is this. Here's what the complementary angle is. These might also be important. What I'm going to discuss here is the possible golden mean aspects, and then I'm going to tell you the ones that I picked out that seemed to make the most sense to me. Maybe they're right, maybe they're wrong, but we have to investigate this thoroughly before we decide. Here's what a complementary angle is. Let's say we do the opposition golden mean angles. So I'm going to start with 0 to 180. And so I take the golden mean, I multiply 0.618 times 180, I get a 111.2. I just rounded these to one decimal to keep it simple for teaching purposes. So I'm at 111.2. This is, if opposition golden mean angles are important, this is a very important golden mean aspect, 111.2. But actually what I've done when I went to 111.2 is I took that 180 and I divided it into two pieces of 111.2. And if I take 180 minus 111.2, I get 68.8. So I've got this red bracket saying, what about the 68.8? It's just your intuition. What do you think? What's your intuition? Do you think that this angle of 111.2 could be important? Taking the golden mean of the 180, since in astrology we usually measure the shortest distance to between 2 points, makes sense to me. And should I use only the 111.2 or should I also use the 68.8? We don't know. But I'm calling that 68.8 a complementary angle. If you're a mathematician, you may go crazy because in mathematics, a complementary angle is the other angle that adds up to 90, and a supplementary angle adds up to 360, and in the context of the way these things are usually used, that terminology makes sense. But in this context, it's like a complement. It fills out the rest of what we started with. We started with 180. So whatever you want to call it, for now we'll call it complementary angle or co-angle. Do you think it's important? Now here's an interesting thing. In this case, 68.8 also shows up here as one of the opposition golden mean aspects. So we've already got it, so it doesn't matter. However, some complementary angles appear elsewhere as like normal golden mean angles, and some do not. So we're left with the question. Here, there's no problem because we already have 68.8 as a golden mean of the golden mean in the opposition reference. But when we get an angle that doesn't show up elsewhere, should we use it or not? You can think about it. My intuition was and still is, we should use it. Like we just split this distance into two pieces. So I don't feel comfortable just using one of the pieces. I feel like that other piece must be important. Maybe I'm right, maybe I'm wrong. But these are the issues, and this is why if you ask, what are the golden mean aspects? Usually people will say, well, Landscheidt said they are these, and then why most people can't answer, and I was not able to answer either, which is, at least not clearly, which is why I want to do this research. What was he picking out? Why? And we will see exactly what his logic is after we map all these out and look at all these angles. So there are many possible golden mean aspects. Let's think about some of them. Golden means of golden means, which I just mentioned. You could do the 0 to 360 golden means. You can do the 0 to 180 golden means. I just showed you that. The black ones are the 0 to 360. The red ones are the 0 to 180. And Landscheidt also did 0 to 90. He just felt like cutting this in half, you should go another level. Well, that's going to add even more. Now, if you do golden means of 90 degrees, all your angles are smaller than 90. So what about between 90 and 180? You would end up with a bias of all these golden means between 0 and 90. So there's this thought that you could add 90 to them as well. So you'd have 0 to 90, and then also 90 to 180. You would add 90 to that. If you're not, this is all simple, but if you're not following it, it's okay. The main point is there's a lot of possible ways to do golden mean aspects. And then you've got the co-angles or complementary angles that I just showed you. When you start working all this out, you end up with dozens and dozens and dozens and dozens of possible golden mean aspects. An enormous number of possible golden mean aspects. The big question is which ones are the most important? We don't know. But what I did is I made a spreadsheet of all these things, examined it, saw where the duplicates show up so that I could see it all. It took a long time to organize this, think about it, and I came up with some conclusions. Okay, so I made a huge Excel spreadsheet of every possible golden mean aspect that I can imagine. I can imagine even more, but within this framework that we were starting with. And there's a huge number. Let me show you the spreadsheet. And in the spreadsheet, I've got some with a green box around them, some with light blue, and some with red. Let me show you the spreadsheet, and I'll explain what these colors mean. So here is the spreadsheet, not the prettiest thing in the world, but this is only part of it. It goes further to the right and further down, but this is what is being captured for this video, and I'll scroll around. You can see the rest of it. Column A is our golden mean. Some of these get covered by these boxes, and I'll explain what the boxes are. But here we start off with the 222.5. This is our golden mean of the whole circle. I put here repeat 0.618, starting with 360, and CO means conjunction. It's another way of saying 360. So this is kind of redundant. 360 is also called conjunction. Over here, I do the 180, also called opposition. And so if we start with the golden mean of the whole circle, we have 222.5, then the 137.5, and then the rounded off 85 and 52.5 and 32.5. I just showed you those in that other diagram of the wheel. And if we keep going, I'll go down, we get 20.06 and 12 and 7, 0.6 and 4.7 and 2.9. We can just keep going and going and going. And we get to very, very small amounts. So all I'm doing is I just wrote down all the numbers. And then I did it with 0.382, just to confirm that 0.382 produces the same numbers as 0.618. So it like skips over every other one, but it does not add anything new. So I put that in gray, that the 0.382 does not add anything. We don't need 0.382. It'll give the same angle. So that's good. It gets rid of half the possibilities because it just replicates what's already there. And now here's the complementary angle. For example, the complementary angle to 137.5, if I do a complement over the 180 degrees, since we measure shortest distance, I get 42.49. And then I've got an arrow here pointing to another 42.49. So when the same angular distance appears another time, I'll draw lines to show that because it's already been taken into account. And the ones that duplicate, maybe they're more important, like they're appearing over and over again. If it appears, as a complement and it appears as a 180 and it appears, it's appearing multiple times, that's nice to know. So I wanted to know everything about these angles, and I made this diagram. Now the green, there's 4 in the conjunction column. Here's the opposition column. There are 3 circled with green. Green rectangle. And then 2 here for the square. These 4 plus 3 plus 2, these 9 aspects are the 9 golden mean aspects that Landscheidt identified. That's them. So we can see what he was doing. He was taking the top ones of the 360, 180, and 90, and he took more of the conjunction, fewer of the opposition, and fewer of the squares. In fact, it's pretty proportionate. The squares is like 1/2 as many as the whole thing. So he's taking fewer and fewer. That's what he did. In another paper, if I scroll all the way down, there's an article he wrote, The Golden Section, a Cosmic Principle, previously published and considered, blah, blah, blah. Here's a website address, and he talks about other golden mean aspects in this article, and I document what they are. I'm not going to go through all of this. He seems to be talking about this more in terms of cycles. I don't know how much he would apply this to natal charts, but he talks about a whole bunch of possible other ones. Maybe these are really important. So it gets complicated, and you can read that paper, and you can read, you could pause this and read what I put here. How he mentions these angles, he does not explain to me. He doesn't explain clearly how he came up with them. So I'm documenting what he did. I figured out what he did. Okay, point is there are a lot of possible golden mean angles. Now, what is the red? The red is where I just went all the way down 9 levels. So starting here, 1, 2, 3, 4 that Landscheidt used, and then 5, 6, 7, 8, 9. I went down 9 levels. By the time you get to 9 levels, the orb becomes extremely small, in some cases about 1 minute orb. So the orb is extremely tiny. I'll explain in the next video how I determine what the orbs are. So the red is 9 levels of the conjunctions, the complement to the conjunctions, the opposition, and the complement to the oppositions. Those look like the big 4 to me. Let me repeat that. The conjunctions, that's golden mean of golden mean of golden mean of golden mean. Then the conjunctions based on 180, same thing. And then that complementary angle that I just showed you. I decided to use all of them. Now, at least explore all of them. I put these into the astrology software. I looked at charts, thought about it. I experimented with using these 4 sets, assuming conjunctions and oppositions are fundamental, and guessing that the complementary angle is also important. And, for example, I do not have this in a red box because it already appeared somewhere else. So, for example, this angle 42.4 already appears here, and I kept the one here. So obviously I'm not going to put the same angular distance in the program twice. It'd be completely redundant. So same thing here. These 3 are skipped. These complementary opposition golden mean aspects because they appear in other places that I've already used. So I end up with these aspects. I end up with 9 in this column, and then 1 or 2, it looks like 1 not needed here, and so on. These I can skip because they were already appeared earlier. And those are my big 4 columns. Now, I looked at the squares. Remember, Landscheidt used the first 2 squares. And what I noticed with all these lines I drew is that the complements to these squares are already used somewhere else. So they're appearing twice. Now it seems to me that if an aspect, if an angular distance is appearing 2 or more times, it's getting repeated as a golden mean in multiple ways, increases my sense that it might be important. So I used only the first 3 of the squares. So I used 9 levels of conjunction opposition, 3 levels of squares. It's a little bit arbitrary, but we don't have clear way through this jungle. And that the fact that these squares, these angles, the complementary angles also appear. I don't have to add them. They're already there. I wasn't sure if I wanted to include the complementary angle of 90. Well, I don't have to because they appear elsewhere. So I added these 3. A big question to me is whether I should include the complementary angle. And also, should I add 90 to these so that they appear? If I add 90, I get 145. Well, I put it right underneath. Add 90 would be the same golden mean put into another quadrant, like shift it over 90 degrees, like move it over 90 degrees. I don't know. We don't know. But this is a good start. Now we can see with this huge spreadsheet what the angles are, what all of the conjunctions are, what all the complementary angles are, what the 0.382 does. We see it. It's all here. It's all documented. And you can see there's zillions of them. Now the light blue is what Linda Berry, who's a leading vibrational astrologer and researcher, she followed Landscheidt, his lead of using the squares, and she did a really elegant, beautiful thing. She used the first 5 of the conjunction, opposition, and the squares, and she added semi-squares. She went one more level to the semi-squares and used the first 5. And there's why 5? Because if we go back to our PowerPoint, I mentioned here the light blue. These are the aspects identified by Linda Berry. And the golden mean has a lot of connections to 5. One of them, and not the only one, is that the formula for the golden mean is based on the square root of 5. It's 1 plus the square root of 5 divided by 2. The really curious thing is the square root of 5. So, because of its connection with 5 might be a good place to stop. It kind of makes sense. And you got to stop somewhere. You'd end up with hundreds of these aspects. How do we prioritize them? So that's what I came up with. Let's look at this spreadsheet one more time. The conjunctions. And I went all the way down. I just said golden means, golden means. You end up with tiny orbs. These things are not going to occur very much. And then the oppositions. And I included the complementary angles. And I included the first 3 squares, because those complementary angles of the first 3 squares also appear elsewhere. They're getting repeated. They might be more important. But should I have gone down and used the 13.13, the 8.11? I don't know. They could be important. They have very small orbs. They're not going to appear very often. And I also don't know if we should add 90. Now, one of the problems is I'm using the Sirius software, and it has a limit of 40 aspects. So it just won't do more. And I ended up with 35. Well, I can't put all these things into that particular program. It won't allow me to, and put them in the wheel. So I got kind of stuck. If I could put more, maybe, I don't know. Maybe I would add these 90s, and maybe I would stop at 5. Maybe I would add all of these. The 55, 145, 34, 124, 21, 111. Well, the 111 already appears elsewhere. 13, 103, 8, and the 98. So there may be a few more that are important. And maybe the complements to them as well. You could end up with about maybe 60 aspects or so. So you got to stop somewhere. We have a clear table of all of these golden mean angles. We can see the logic behind them. We can see how overwhelming it is, how many there are. These things are important. We have research that shows they're important, and it will help to to better identify which ones are the most important. And so now we have a good idea. So that's how I did it. What I'm going to do in part 2 of this series, probably a 2-part series, I want to show you. I want to show you how I determine what the orbs are, and I want to show you what it looks like in this, how I set the colors for the aspects. It's, I think, a fairly clever color scheme, so that you can look at a wheel and see what kind of golden mean aspect is there. And then I want to show you an example of a chart wheel that has a huge golden mean pattern. Okay, I'll show you that in part 2, and then we'll have completed this. This video is a little bit longer than usual, 40 minutes. So anyway, I'll see you in part 2, and we'll cover these last few topics of the orbs, what they look like in software, how you can set the colors and other features of lines. And let's see an example of a chart after all this. Okay, thank you very much for listening, my friends. God bless. Namaste.